So a person I know asked me to help them with this question. I thought I'd just upload it on my channel because I haven't uploaded on my channel for quite a while. This question is actually somewhat easier compared to other questions I upload on my channel, but either way, if it helps somebody, I mean, that's the point of the channel, I guess. So basically, we have a circle and then we have two tangents, xy and x dash y dash. And there's another third tangent, AB, which intersects xy at A and B and intersects the circle at C because it's a tangent, that's where it must intersect. And we have to prove that the angle AOB will always be a right angle. Right angle, yeah. So I thought first thing we would do was actually draw the line from the center of the circle to the tangent x dash y dash. Alright, so because it's a tangent, first name the point before doing anything actually. Name this A, B, C is taken, so we'll start from F, I guess. Call this F. And yeah, because this is a tangent, x dash y dash is a tangent, this must be 90 degrees. Now similarly, we can do over there on xy. So somewhat like this. I like the new feature they added on Microsoft Whiteboard in which you can draw straight lines. Makes geometry much easier to do. Anyways, I'll name this point G. And same way as this will also be a right angle. Alright, so now if we notice xy and x dash y dash are parallel, which is given to us. I think I forgot to mention that. God damn. Yeah, I forgot to mention it, but x dash and y dash and xy are two parallel tangents of the circle. So that's why if you notice, OG and OF must be a straight line because this is 90 degrees, this is 90 degrees. So GF actually acts like a transversal because in parallel lines, the interior angles are actually equal to 180 degrees, which we can see here. So GF is actually a straight line. So GF is transversal over here. Now next thing we'll have to notice is I'll get my pen out. I'll go with red actually. So because AC and AG are tangents, these two are equal. AC and AG are equal. Now one more thing we'll have to construct before we move on is that we'll construct one line between O and C. I think now we're ready to go. Okay. So now we know that AG equals to AC. Now OG equals to OC. I'll tell you why. Because OG and OC are actually radius of the circle, and by the properties of circles, the radius has to be same. So OG and OC must be equal, and AO is common. So I guess I'll write it down. Just right over here. AG equals to AC. AC. Now second thing is OG equals to OC. OG equals to OC, and we see that AO is common. So if you might be able to notice, you're actually going through, we're trying to prove congruence over here. AO is common. AO is common. So we can say the triangle AGO is congruent to triangle AGO is congruent to triangle ACO. So triangle ACO by, I think, SSS congruency, but we don't need to write that down. Now let's move on to the next triangle. I'll get used to that pen. So similarly, CB equals to BF because tangents, right? And OC equals to OF. So what we'll notice is uh, that this can also be proved by, we can use a congruency of triangles over here too. So I'll put it in the right side. OC equals to OF because radius of circle, C equals to OF. OB is common. Yeah, and BF equals to BC. So now we can prove congruency over here. BF equals to BC, so triangle triangle OFB is congruent to OCB. OCB, and this is by SSS, but no need to write it on really. And now we'll have to do the CBCD thing. So angle GOA. I'll use a different color for this. I'll use this here. Angle GOA. Angle GOA equals to angle AOC. GOA equals to angle AOC by CBCD because these triangles are equal. I mean congruent. Over here we can do the same. Angle OBF, not OBF, GOA, so angle COB. COB equals to angle BOF. Same with CBCD. So now I think I said it in the start, but GF is a straight line. Either way, we'll prove that over here itself. An easy way to actually have a look at this is to actually prove that GF is a straight line will be by the fact that GF is actually equal to 2 times the radius. If you have a look, there's one radius and this is the second radius, right? And it goes through the O. So this is actually a diameter. So, and diameters are straight lines, so GF is a diameter. I'll use a different color. GF. I used this already. GF. GF is a diameter. Thus, it's a straight line. I think this is a very basic thing, but either way, let's write it down. Everything should be written down. I guess is the diameter. GF is a diameter, and thus it has a line. So if you look at the angles of a line add up to 180 degrees, right? So this is pretty much like the ending part of the thing. So if you have a look at the angles GOA plus AOC plus COB plus BOF equals to 180. But it's given to us that I mean, we just proved that GOA equals to angle AOC and this over here. So we can actually substitute GOA by angle AOC and substitute BOF by COB. So then we'll get something like, just write the rest down. 2 angle what? 1 second, 2, sorry. 2. So we can say 2 angle AOC plus 2 angle BOC is equal to 180 degrees. So if we divide both these sides by 2, we can do angle AOC plus angle BOC. (90 degrees), or in other words, angle AOB equals to 190 degrees. So this was actually quite an interesting result to find out. Well, either way, I guess this is where the video ends.